Okay, geometry students, in this video today we will be studying angle and segment addition. We will also get our first postulate of the year, so that should be interesting. Let me get my program working here. There we go. Your heading today, please go ahead and write this in your notes if you would, please. Your heading today is angle and segment addition. Angle and segment addition, lesson 2.2. Also include today's date if you would, please. Include today's date. And let's continue on. Please take some really good notes today. Let's first start by explaining what a postulate is, okay? We're going to be learning a lot of postulates this year, so it's very important that we know what a postulate is. So please write this in your notes if you would, and you're responsible for this information on tests and quizzes, okay? A postulate is a rule or principle that one accepts as true. A rule or principle that one accepts as true. Now, usually postulates are easy to understand and they're accepted as true because they are obviously true, okay? Now, this would not be a postulate 2 plus 2 equals 4, but if it were a postulate, that would be easy to understand and it would make total sense, okay? And that's what postulates are. They're easy to understand, they make sense, and so they're accepted to be true, okay? We're going to be looking today at 4 postulates, okay? 4 postulates, and 2 of them I call duh postulates, kind of like duh, that's just common sense. And I'm not going to ask you to memorize these. They're really simple and they're really just common sense, and we use them not every day, but we use them all the time, and we just understand that they're true. So I'm not going to make you memorize those 2 postulates, but the other 2 postulates you will be responsible for. Okay, so let's continue on. The other 2 are important, and as I just mentioned a second ago, and you will need to know them for future tests and quizzes, okay? Let's first look at the 2 duh postulates and then move on to the 2 more important information, okay? So do not write this in your notes. Do not write this in your notes, just listen to it. Let me explain to you what it's saying, and then we're going to move on, okay? The first postulate is called the Ruler Postulate, and it states this: the points on a line can be matched 1 to 1 with a set of real numbers. The real number that corresponds with the point is the coordinate of the point. The distance AB between the 2 points, A and B, on a line is equal to the absolute value of the difference between the coordinates of A and B. Basically, all that's saying, students, this is so easy to understand, is that every segment is measurable. That's all that it's saying. Now again, please don't take notes on this. I'm going to be really, really brief, okay? But if I have a segment here and I have a number line, and I'm going to put a 0 here and a 1 and a 2 and a 3 and a 4, and I'm almost done. We're not going to spend a lot of time on this postulate at all, okay? But if I picked this up, and did not mean to pick that up, hold on one second please, and I moved this segment down here and put it right here. And let's pretend just for a second, if we can stretch it out here to the 4 just to make it easier. There we go. Okay, so this segment rests on -1, 4. How would I find the distance? Well, I could count 1, 2, 3, 4, 5, but another way is to subtract the 2 numbers, -1 minus 4, and you get -5, and then take the absolute value of that and you get 5. That is all that this postulate is saying. It's just simply saying that every segment is measurable by subtracting the 2 coordinates of the endpoints of the segment. Let's pick this up. If it was here, let's say it rested on 0, and then right here it was 5. Well, obviously the distance from 0 to 5 from A to B is 5. And that's all that this postulate is saying. It's just simply saying that every segment is measurable, and it's measurable. Sorry about that, students. There we go. And let's go like that and that. It's measurable by simply counting the distance from one to the other, and you can measure any segment by placing it on a number line. That's all that segment is saying. That's all that postulate is saying. We do not need to know that, and we know, hopefully, how to measure segments on a number line. For example, if I asked you to find the distance from here all the way over to here, you should know how to do that. You subtract the two numbers. You could say 4 minus a -2, or you could say -2 minus 4. Either way, you will get 6 or -6, and distance is never negative, so we make it positive. And that's all that this postulate is saying. Nothing more, nothing less. It's really long. It's not necessary to memorize that, okay? Here's the next postulate, and you do not need to write this down. I'm going to read it to you, then explain what it's saying. Postulate 3, the protractor postulate. The rays of the form OD, where D is in P, can be put in one-to-one correspondence with the real numbers between 0 and 180 inclusive. Students, all that this is saying is this: any angle is measurable. If we have an angle, we can measure it with a protractor. And when we measure it, it's going to fall between 0 and 180. Well, we already know that. We know this first postulate here, that any segment is measurable. And we know this postulate here, that any angle is measurable with a protractor. And so these are really, we use this information all the time, but I'm not going to make you memorize this information, okay? That's not necessary to do. All right, let's continue on. Now, this postulate here is real important, so please copy this in your notes. This is called postulate number 2, segment addition postulate. By the way, students, I will never make you fill in the blanks on any of this part here, okay? Whatever you have to fill in the blanks in will come from this part over here, okay? So postulate 2, which is called the segment addition postulate, reads as follows. If B is between A and C, then A plus B, AB plus BC equals AC. Now please copy this in your notes. You need to know this, and I want to talk a good deal about this, so please take some really good notes. First of all, let's talk about this word between, because this word has a special meaning in geometry. Are you ready? Write this down, please. Whenever in geometry it says a point, like B, for example, is between points A and C, the word between means collinear. Now let me explain. Listen, if I told you B is between A and C, now watch, just don't take notes, just watch this. Here's A, here's C. If I put B up here, in our English language, we would say that B is between A and C. You would say, well, here's A, here's C, and B is in between them. But in geometry, when we say that a point is between 2 points, it automatically means that this point right here, this B, is collinear. So first of all, understand that when this postulate states that B is between A and C, it means all three of these lines, all three of these points are on the same line. And then it means B is between A and C. Now what it does not mean, it does not mean that B is in the middle of A and C. That is not true. Are you getting all this? Take some really good notes. The word between means collinear. All 3 points are on the same line, but it does not mean B is in the middle. B could be way over here, okay? And then C could be way over here. None of that matters. So when it says if B is between A and C, what it means is B is between A and C, and all 3 points are collinear. And when this happens, now look at this, AB, that means this segment right here, plus BC, this segment here, equals the entire segment AC. And doesn't that make sense? I mean, think about that for a second, students. If I told you the measurement from A to B, from here to here was 6 inches, and I told you the measurement from B to C was 5 inches, and I asked you to find the measurement of AC, you would say, well, that's easy. The measurement of AC has to equal 11 inches because 6 plus 5 equals 11, so the whole length is 11. And that is all that postulate 2 is saying. It's saying if B is between A and C, then AB plus BC equals AC, the entire segment. Okay, let's move on to one more postulate, and then we're going to look at 4 or 5 examples, and then we'll be finished for the video. Okay, students, postulate number 4, angle addition postulate. Okay, postulate 4, angle addition postulate. Please copy this in your notes. You definitely need to have this in your notes, so copy this down. If C is in the interior of angle AOD, then the measure, that's what this M stands for right here, the measure of angle AOC plus the measure of angle COD equals the measure of angle AOD. Alright, so if C is in the interior, let me pause and say this once again. Please copy this down, okay? So I'm going to pause just a second, copy that down, and then I want you to take some really good notes about what this postulate means, okay? So C is in the interior of angle AOD. So please copy this in your notes if you would. We're going to call this angle AOD. Please put this in your notes. And then notice that it says here, student, C is in the interior of AOD. So I'm going to draw another ray, and I'm going to put C right here in the interior. Okay, students, so let's see if everything matches so far what it's supposed to match. C is in the interior of angle AOD. That's good. Now look what I have here. Please listen to what they're saying, students. If C is in the interior of angle AOD, and it is, here's angle AOD. There it is. Here's the interior of that angle. And notice how C is in the interior, okay? So if C is in the interior of AOD, then, now watch this carefully, then angle AOC, which is this angle right here, plus this angle here, COD, which is this angle here, COD, equals angle AOD, which is this whole angle right here. Doesn't that make sense, students? Think about that. If I told you this little angle right here was 20 degrees, and I told you this angle right here was 30 degrees, and then I said to you, I asked you to find the measurement of this whole angle right here, angle AOD, would you not add 20 degrees plus 30 degrees, and this entire angle would be 50 degrees? Doesn't that make sense? I think it does. And that's what this postulate is saying. It's saying if you have an angle with a point in the interior with a ray like this, these two angles here, when added together, are going to equal the entire angle. And that's what postulate 4 is saying. Okay? So with with all of that in mind, let's go ahead now and work out about 4 or 5 problems together and practice this information to make sure we really understand it. Okay? So here we go. Students, turn in your books to page 67, okay? Take a second and do that while I'm rambling on here. We are going to look at numbers 2 through 6 at the top of the page. Now, I want you to take notes on these problems and take really good notes, okay? And my advice to you is to label each problem with the page number and the problem number. Okay, you don't have to do that, but that's my suggestion to you. So again, go ahead and turn your books to page 67 if you would, really quick, and we're going to look at numbers 2 through 6. And my advice to you is label each problem with the page and then the number. So here we go. Number 2. In the diagram at the right, which is this diagram right here, 2 is the coordinate of A and 9 is the coordinate of B. So here's A and it matches up with 2. Here's B and it matches up with 9. Find AB, or in other words, find the length of AB. Well, that's easy to do. I can take 2 minus 9, and that would give me -7, and we know that distance is never negative, so it's 7. Or I could take 9 minus 2, and I would get 7. Either way, I'm getting 7 for the distance or the length of AB. Or I could just count, put my pencil here and go 1, 2, 3, 4, 5, 6, 7. Okay? So we found the length of AB. Now, use the same ruler to assign different coordinates to A and B, and does the distance change? What they're saying is this, and it's really an overkill. This is very easy math here, I do believe, for you to see. But what they're saying is if you slid this segment down so that A went down 3 units, 1, 2, 3, so it was at 5. So pretend A is right here, okay? And then we also slid, B would also slide down 3, so 1, 2, 3, right here to 12. So A is now here, and B is now here. So I picked up this segment from here to here, and I slid A to 5, and I slid B down to 12. Does that change the length of the segment? And the answer is no. If A is on 5 and B is on 12, 5 minus 12 is still -7 or 7, and 12 minus 5 is still 7. So no, it does not matter where you move this segment on a ruler or on a number line. The distance of it is still going to be 7, and that's what they wanted you to see. Okay? All right, please copy in your notes. Page 67, number 3. Page 67, number 3. And the problem reads as follows. Let M be between, oh, don't forget between means collinear. They're going to be on the same line. Okay? Let M be between points L and N. State the segment addition postulate. Okay, this is easy. Let M be between L and N. So here's my line. Here's L. Here's N. And M is between them. Now they want us to state the segment addition postulate. Well, sure. Would it not be LM plus MN equals the entire segment LN? Sure it would be. If I told you LM was 5 and I told you MN was 2, then you would know the entire measurement from L to N would be 7. 5 plus 2. So LM plus MN equals LN. And here's the answer right here. Okay? Let that sink in for a second. It's really important that you see that because we're going to use this a lot in proofs. Okay? And number 4 is really tough, so please pay attention. Okay, here we go. Please copy in your notes, page 67, number 4. Page 67, number 4. Okay, using this diagram here, how can you determine BD? In other words, how can you find the length of BD if you know the lengths of BC and CD? So let's just use numbers to make this really easy, okay? How can you find the length of BD if you know the lengths of BC and CD? Well, let's pretend that BC is 8, and let's pretend that CD is 5. How would you find the length of B all the way to D? If I know that BC is 8 and CD is 5, how would I find the length of BD? Well, would I not add these two numbers together, 8 plus 5? Sure I would. So the answer that they're looking for is this. How would you find the length of BD? You would say BC plus, here's BC, BC plus what? CD. That's how you would find the length of BD. Now, they throw another problem at you, and this was a lot more difficult. How would you find the length of BD if you knew the lengths of AB and AD? This is tough. Let's look at this again. How could you find the length of BD if you knew the lengths of AB and AD? Well, let's use numbers again to help us here, okay? Let's say I knew that from A all the way down to D it was 10, okay? And that's what it says here. It says I know the lengths of AD and I also know the length of AB. So from A all the way down to D is 10. And then let's pretend that AB is 2 from here to here. How would I find the length? Let me get my green pen out. How would I find the length of BD? From B all the way down to D. Would I not subtract? I mean, if the whole length is 10 and this much is 2, if I take 10, the whole length, and then minus 2, I would then know that BD is what? 8. So in this situation here, I'm going to subtract. So how would I find BD if I knew AB and AD? Well, I would take the whole length, AD, and I would minus the length of AB. So AD minus AB. And that's how I would do that, okay? And if you'll look here, you'll see both answers that we already gave. One answer was BC plus CD, and the other answer was AD minus AB. Now this was a tough one, so I hope this is making sense, okay? You might have to go back and watch this again at a later time, but this is just taking the segment addition postulate and applying it, okay? Number 5. Number 5 and 6, and then we'll be finished. Okay, let Y be in the interior of XOZ. So very quickly, here's X, here's O, here's Z. Take some really good notes on this, please. Let Y be in the interior. So here's this, and here's Y. Okay, state the angle addition postulate. So here we go. We're going to call this angle 1 right here. And we're going to call this angle 2. Now angle 1 right here is angle XOY. So the measure of angle XOY. And then angle 2 is this little angle right here. And that's the angle of what? YOZ. So I would say the measure of angle XOY plus the measure of angle YOZ equals, now if I'm taking this little angle right here with 1 dot and this little angle here with 2 dots and I'm adding them together, I'm getting this entire big angle right here. So the measure of XOY plus the measure of YOZ equals the measure of angle XOZ. XOZ, this whole angle, okay? So you just stated the angle addition postulate using those angles, okay? And then last but not least in your notes, let's take a look at page 76, number 6, okay? And then we'll be finished for the class period. Let's see. How can you determine the measure of angle AOC? Now here's AOC. Look at it carefully. Here's A, O, and then C, okay? How can you find the measurement of AOC if you know the measure of AOB, which is this little angle right here, I'll put a dot, and BOC, which is this little angle right here, I'll put a dot. Now students, that should be pretty easy for you to see. If I know this angle here is what? Would it say 20 degrees? And I know this little angle right here is 10 degrees. Then how would I find this angle here that combines those two angles? Well, I would take 20 degrees plus 10 degrees and I would get 30 degrees, and that would be the answer. So what I did is this. I added angle AOB plus the measure of angle BOC. There we go. And by adding those two angles together, I would know the measure of angle AOC. Now, the last part of this problem is pretty difficult, so I'll do the best I can to explain it, but please pay attention, okay? If you know the measure of AOD, so here it is, A down to O, and then O to D, so you know this whole angle, okay? And COD, so COD, okay? If you knew the whole angle and that little angle, how would you find the angle from here to here? Angle AOC. Well, let's use numbers and see if that helps, okay? Let's pretend this whole angle from here all the way to here is, I don't know, we'll say 40 degrees, okay? 40 degrees. And then this little angle right here, COD, which is the angle I know. I know the big angle, angle AOD, and we're going to say it's 40 degrees. We're just making that up. And then angle COD, we're going to say that little angle is, I don't know, we'll just say 10 degrees. Now think about this, students. If the whole angle is 40, and this little angle right here is 10, how would I find this angle that goes from this ray to this ray here? Would I not take the whole angle, which is 40, and then subtract out the 10 degrees, and then and then I would know this angle from here to here has to be 30 degrees. That's exactly what you would do, okay? And I'm hoping that using numbers like this is helping you see that. So I take my entire big angle, angle AOD, and I subtract from it this little angle right here, which would be the measure of angle COD. And if you do that correctly, subtract those two angles, what you're left over with is angle AOC, this angle right here, okay? It's been a pretty tough video. Hopefully you guys are getting this okay. If you have any problems, you might have to watch bits and pieces of it again. But if you have any questions, don't hesitate to call or email.